Okay, guys, today we're going to look at another method for solving systems of equations, and it's called elimination. And what we're trying to do is we're going to try to eliminate a variable. And so similar to the substitution is we're trying to get one variable so that we can solve for it so we can find the other variable. So if we start out with this system, 4x minus 2y equals 7. And x plus 2y equals 3. If we look at those two equations, what do we notice that are similar? One is they both have an x, they both have a y. But then if we look at the y coefficients, one of them is -2 and one of them is +2. So what happens if we actually combine those two together is we get a 0y, which eliminates the y. And so what we're allowed to do, one of the things we can do in algebra is we can always add two equations together. And so what we do is we just kind of put a plus sign and we're just going to add these together. So in this problem we have 4x plus 1x is 5x. -2y plus 2y is 0y, so they cancel out. And then 7 plus 3 is 10. And this makes it to where we can solve for x very easily by just dividing both sides by that 5. And that gives us x equals 2. Okay? Once you get that one variable, it's the same process that we did the last time. We're going to take that value and we're going to plug it back into one of the equations. I'm going to choose the second equation because it's the easiest because I do not have to multiply anything times that 2. So when I replace that, it becomes 2 plus 2y equals 3. And then I just solve. So I'm going to start out by subtracting 2 from both sides. It gives me 2y equals 1. And then the next step is to divide both sides by 2. So y equals 1/2. So my ordered pair solution is 2 1/2. Okay. So, process of elimination is definitely easier to use if you have opposite coefficients on one of the variables like we did here with the -2 and the +2. Okay, it's considerably easier if that's the case. Okay. So let's try to do another one like this. And I'll kind of slow down through it so you can see a little bit easier. I'll do just a tad bit different, but it's going to be very similar. So the first equation is 4x plus 9y equals 1. And the second equation is 4x plus 6y equals -2. Alright, so first question is, do we have any coefficients that are opposites? And the answer is no, but we have two that are the same. Okay? One of the other rules are that you can multiply any equation by a number. So the number we could use is -1, and that would make one of those equations opposite. So if I multiply this whole equation by a -1, second equation, all that's going to do is change the sign on every one of those terms. That'll make that a -4x, a -6y, and then a +2. And now I can just add, and my x's are now eliminated because 4x plus a -4x is 0. Then 9y plus a -6y, that's pretty much -6y is 3y. And then 1 plus 2 is 3. To finish solving to get y by itself, I get rid of that 3 there. 3 divided by 3 is 1y equals to 1. Okay, what's the next process? We go back to one of the original equations and plug it in. So let's go down, too far. So we have 4x plus 9 times 1 equals 1. And then just evaluate for x. So 4x plus 9 equals 1. Get rid of that 9 by subtracting it from both sides. So 4x equals negative 8. And get rid of the 4 by dividing both sides by 4. So x equals negative 2. So my solution is x comma y, so it's negative 2 comma 1. Okay. So steps for today. 1. Eliminate the variable that has the same or opposite coefficient by adding the two equations together. 2. Solve for the variable that remains. 3. Use the value for that variable to plug into original equation and solve for the remaining variable. Yeah, that's it. We're going to do one more piece of this tomorrow when there's not a coefficient that's the same. That's a little bit more difficult, but I think it's still easier than substitution. But this will be a good introduction into it. So we'll stop there today.